If the red supergiant star Betelgeuse were to explode right now, we would witness a spectacle of the millennium. The sky would be on fire, and the night would be as bright as day. Betelgeuse is about to explode, that much is certain. However, scientists are not in complete agreement as to whether shortly is tomorrow or in 1,000 years. It's also possible that Betelgeuse has already exploded and we haven't even noticed it yet. A supernova explosion occurs in our Milky Way about every 50 years. However, supernovae visible from Earth only occur once every 1,000 years. Betelgeuse, which is about 640 light-years away from Earth, will be a Type 2 supernova, and they are particularly spectacular. During the day, the explosion of Betelgeuse would dramatically change the brightness of the sky. Although the sun dominates the sky, the supernova would be so bright that it would be visible even in daylight. The brightness would briefly blind drivers and pilots, similar to a sudden flash of lightning. Caution would be advised, especially at dawn or dusk, when the sun is lower and the brightness of Betelgeuse hits people's eyes abruptly. This extremely bright flash would only shine for a moment. Then we would see a bright spot of light that would appear like a new, extremely bright star. However, no sound would be audible, as sound waves do not travel through the vacuum of space. At night, the explosion would appear even more spectacular. For a moment, everything would be illuminated, and then we would suddenly see a new, extremely bright point in the night sky that would shine brighter than Venus and Neptune. This new source of light would probably be as bright as the full moon and could bathe the night landscape in a wonderful light for weeks. We would probably not see the stars near Betelgeuse during this time, as the intense light from Betelgeuse would simply outshine them. Everyone just looks there. While it's certain that Betelgeuse will explode, it is still uncertain when it will explode. Astronomers around the world are keeping the star under constant observation, and even some satellites are pointed at Betelgeuse around the clock. Every change, no matter how small, is registered immediately. When the supernova alarm goes off, astronomers and amateur stargazers will immediately point their telescopes at the event. Space telescopes such as the Hubble Space Telescope or the James Webb Space Telescope would take detailed pictures. The observatory's measuring instruments would register an enormous increase in brightness across the globe, accompanied by an increase in gamma rays and X-rays. Radio telescopes will detect drastic changes in the radio wave range on this very special day. And the gravitational wave sensors, which register even the finest changes in the cosmos, would very probably indicate the explosion even before we can see it. Gravitational waves are tiny changes in the gravitational fabric of the cosmos. All events in the universe in which matter is in motion generate gravitational waves. In addition to gravitational waves, unusually high neutrino currents would very probably reach us. The world's best neutrino detectors in the Arctic and Antarctic would very likely also be among the first to register the supernova. What happens after the explosion? One thing is certain, Betelgeuse will disperse incredible amounts of matter and energy into space. The components of the star will spread across the galaxy over billions of kilometers and light-years. The blast wave from the explosion will have a significant impact on Betelgeuse's immediate surroundings, and yet the distances in the universe are so vast and large that it's uncertain whether neighboring stars will really suffer serious damage. Betelgeuse is the first red supergiant star to explode directly in our cosmic neighborhood, and it's the first time we can witness the spectacle with modern technology. It will be a surprise to be able to study the true scale of the explosion for weeks. Shortly after the explosion, Betelgeuse would remain visible as an extremely bright spot in the sky for weeks to months. Over time, the brightness would gradually diminish. This means that we will no longer be able to see it with the naked eye, but astronomers will continue to observe any changes, however small, with their telescopes. After the end of Betelgeuse, an extremely compact remnant will remain, either a neutron star or a black hole. Betelgeuse may even form a spectacular cosmic nebula, such as the colorful Crab Nebula. That would of course be a very special spectacle. Such nebulae can exist for millions of years. This means that old stars do not disappear completely, but leave behind an object or black hole that offers us plenty of material for research. The life of a star. What Betelgeuse used to look like. Do you also wonder what Betelgeuse's life as a star looked like? We humans like to be sentimental and look back. So let's reconstruct Betelgeuse's life together, and I'm sure there will be a few surprises. About 10 million years ago, Betelgeuse was formed in a dense molecular cloud. This cloud of gas and dust consisted of materials traveling freely in the universe, and it also consisted of the remains of earlier supernovae. Betelgeuse was thus formed from the material of older stars. At some point, this cloud became so heavy that it began to collapse under its own gravity. A protostar initially formed within this cloud, which accumulated more and more mass until nuclear fusion was initiated. Betelgeuse was not alone. The young star was formed in a cosmic nursery full of newborn stars. This luminous and chaotic region may have resembled today's Orion Nebula. The environment of the star nursery was characterized by strong winds and high UV radiation. Betelgeuse was an extremely massive star from birth and was probably significantly brighter than its siblings. As a massive star, Betelgeuse had a shorter life expectancy than smaller stars from the start. It used up its fuel supplies relatively quickly. In its core, hydrogen atoms fused to form helium, and in the process, the giant star released incredible amounts of energy. This phase lasted only a few million years, the blink of an eye in cosmic time. During this time, Betelgeuse was probably a blue supergiant and 1,000 times hotter and brighter than the sun. In the middle of Betelgeuse's life, the hydrogen supply in the core was already exhausted, and the star began to fuse helium into carbon and oxygen. It was precisely at this stage that Betelgeuse slowly began to blow up into a red supergiant. Its brightness continued to increase, and it began to periodically lose large amounts of matter in the form of strong stellar winds. At that time, the red supergiant already had a diameter larger than the orbit of Mars around the Sun, and its bright red color fascinated people on Earth. An interesting question is, of course, how planets around Betelgeuse might have experienced this development. Similar to us, Betelgeuse could have gathered a colorful group of planets around it. Some experts consider it impossible that life could have existed there, as we currently assume that life needs billions of years to develop. And given Betelgeuse's short lifespan, this would be rather unlikely. Nevertheless, we can never rule it out because we lack comparative values, and we would probably be making a drastic mistake if we tried to transfer the earthly conditions to other worlds. What is certain is that the planets around Betelgeuse became hotter and hotter. As the star grew, it gradually swallowed them up. If there had ever been life there, it would have been destroyed by the star's extreme radiation alone. Betelgeuse shatters in a fraction of a second. The magical thing about cosmic events like these are the incredible forces and time sequences we are dealing with. The upheavals in Betelgeuse's inner being alone are so enormous that we can hardly grasp them with our minds. When Betelgeuse had also used up the helium in its core, it began to fuse heavier elements: carbon, neon, oxygen, and finally silicon, which fused to form iron. This process went faster and faster, and at the same time, each fusion stage produced less energy. As the heavy elements increased, Betelgeuse became heavier and heavier, and at some point it would collapse under its own gravity. Then it will tear the enormous star apart in a fraction of a second, and all the remaining energy will be released suddenly. How close is Betelgeuse to exploding? The question on everyone's mind is, when will it happen? When will this star explode, and will we see it? Betelgeuse is increasingly unstable, as all observations show. It's definitely in its final phase, but how long that will last is a mystery. Astronomers are using a variety of telescopes and technologies to observe Betelgeuse closely. In addition to the Hubble Space Telescope and the James Webb Space Telescope, the European Southern Observatory's Very Large Telescope and the ALMA Telescope in the Atacama Desert take turns observing the star. These telescopes' analyses show us chemical compositions and changes in its brightness. Between the end of 2019 and the beginning of 2020, the star's brightness decreased by around 25%, which attracted worldwide attention and triggered speculation about the imminent supernova. However, after intensive investigations, astronomers concluded that the dimming was probably caused by a combination of different factors. A huge cloud of dust ejected from the star and large-scale convection cells on the star's surface, which were cooler than the rest of the star, obscured the star for weeks. Scientists also observed another, albeit less dramatic, dimming of Betelgeuse in 2024. This event is thought to be a direct after-effect of the Great Obscuration of 2020. Although all of these phenomena can be explained, they show us how unstable the star is, and they can be taken as important clues that Betelgeuse may soon explode, or has already exploded. The crazy thing is that the star could have gone supernova long ago, even hundreds of years ago, but we won't see its light until 650 years later. What will change? Many people regularly look up at the Orion constellation because it is one of the most famous and impressive in the night sky. Betelgeuse glows reddish in the right shoulder of the mythical hunter, which is revered and mythologically significant in many cultures around the world. In Greek mythology, Orion is described as a mighty hunter who is loved by Artemis, the goddess of the hunt. His image in the sky symbolizes strength, courage, and a thirst for adventure. Betelgeuse, with its striking red color, has always held a special fascination and inspired many stories about gods and heroes. When Betelgeuse explodes, Orion will be changed forever. The bright dot that once watched over us as a protective star will be replaced by a glowing supernova and eventually darkness. It is an emotional thought that this familiar celestial body, which has accompanied us through the millennia, will soon be gone. The loss of Betelgeuse will remind us that the universe is also in constant flux, and that even the seemingly eternal stars are subject to a cycle of birth, life, and death. Subscribe to the channel now. There are many more exciting videos to come.